Hello guys, Matt from Mr. Enforcer. I've got a new 20B build going on. We thought we'd give you guys a bit of a rundown on exactly what is included and what you get in a brand new 20B build. So this one's for Tom Seaton over in the UK. He's ordered a billet 20B engine. It's going in an FD RX-7 streetcar. Now when we say you get a new parts build, it is exactly that. You get a new parts build. So starting from the front of the engine, now he's opted for a billet boss billet timing cover. So obviously you've got your front hub, your bearing for the timing cover. Stationary gear bolts, they're new. When you do go to a billet engine, you use a half head cap screw as the extra bolts to hold the front stationary gear in. Only thing that we don't have new is actually a oil pump drive. That's the only part of the whole engine which is not new. We've got, what have we got? Okay, we've got counterweight, new Mazda OEM counterweight. Now obviously holes are in there for the balancing. New thrust. We've got station there for stationary gear. Crank angle sensor drive. So we've got a new crank angle sensor drive. We've got our new Torrington bearings. So we've got two bearings. We've got the thrust plate. That's new. Front keys new. We've got oil pump. So we get a new oil pump, the new oil pump wheel, the nut, the washer, the keyway to drive. Stationary gears. Now in the street engines we do still use the OEM Mazda 20B stationary gear. Now maybe a smart move, maybe a lucky move. I bought 70 of these back in 2003 or 2004. And I remember the Mazda dealer saying, what the hell do you want to do with that many stationary gears? Well, paid off. Okay, so we've got our rotors assembled. We've got our oil rings, springs, all new O-rings, side seals and springs are all in, corner seals and springs are all in. We've got our apex seals. Now I've gone ahead and I've pre-glued the assist piece on. All the springs are laid out, so we're pretty much ready to assemble this engine now. What we'll do is we'll put the crank up and we'll just double check our bearing clearances and then we'll start the assembly. Alright, with that crank up, the first one we're doing, we build a 20B, is the center one, so we'll check the center rotor. Lock that off. Now we use a dial bore gauge. Now this is what we're going to use to measure the internal diameter of the bearing. We're not looking for a specific number, we just want a 0. So pop that in there. Okay, that's our 0. Now put our calipers on here. So with that set, what I'm looking for is around 3 to 3.5 thou. I'll check that. Whoop. So with that, we've got just under 3.5 thou, which is within what we want. And then to make sure our journal isn't egg or it isn't tapered, we'll just take another couple of measurements randomly. Yep, so that's parallel. So next up we'll want to check our center stationary gear bearing journal. We'll check that, see what bearing clearance we have there. Now on this one I'll be looking for around 4 to 4.5. Alright, so on this same deal, here's a dial ball gauge. Let me just check. What do we got? Okay, we zero that. Alright, again, we just put our calipers on and check what we've got. So we've got on that about 4 1/4 thou of bearing clearance for the main centre gear. Now this is where getting the cranks made to size saves a whole lot of time. If, for example, I had 3 1/2 thou clearance when I measured that, and I want the 4 to 4 1/2, I'd have to polish 1/2 thou to 1 thou off this journal here. Now at 40 Rockwell, that's the material hardness, that's going to take quite a deal of time. It's time that can be eliminated by knowing what you want and ordering the crank with the right size journal. The other thing that we check is make sure that the bearing's not egg-shaped. I have had bearings before where they've been an egg. Now it's mainly on a gear where someone may have pushed a bearing into it, and the bearing hasn't gone in square. So it's important to have the bearings pushed in properly. Okay, so we're zero. Draw that down. Okay, so the bearing is true, it's round and it's parallel. I'm going to use a bit of assembly lube. Whoop. That's more than a bit. The main thing I want to do is get it on the gear and the bearing, so that when this thing rotates, I know the gears and the bearings are lubricated. Nothing's going to have that initial run dry on startup. So our center plate's up, we've installed the gear, we've installed the wear plate, we've got the O-rings installed behind it, we've got our water retention seals in place. Now the main thing that we'll look at, whether it's a new engine or a used engine that you're building, is that your legs are flat. The last thing you want is any dents, burrs, build up of old silicon up around the dowel area. What that's going to do is you're not going to be stacking a square engine, you're actually going to be stacking an accordion. So to make sure that the center bore remains straight and true, you want to make sure that everything is flat and clean before we drop a housing on there and start stacking. Now on this build, Tom has opted to use some FD rotor housings. Obviously all new, being a new engine. The first thing we do with our builds is we'll machine off the spark plug bosses. That saves having to machine down a socket to try and get the spark plugs out. They've also we've done the exhaust port on them, and the machine work's been done for the studding. Tom wanted a polished engine, so we've polished the housings, and the plates have also been polished. One of the things you'll notice on new rotor housings these days that you probably didn't see 20 years ago will be imperfections in the castings. Now you'll see, even though these are new, we have run a stone over the entire surface. Because work has been done on the housing, they've been up in the mill twice on the bench to get the exhaust ports ported, finished off. No doubt there's going to be a chance that you could get some bruising or any scratches in the surface, so we just run a stone over them to make sure that they are flat. Now this is what I'm talking about with imperfections. I've seen these even right across where your water retention goes. There you go, there's one right there. Now in instances like that, these are from Mazda, where they have put some epoxy in them to make sure that they are flat. It's just a porosity in the casting. So what we'll do when I assemble this engine is I'll put a very light amount of silicone just over those areas to ensure that if there is any kind of divot at all, especially in something like that across a water seal area, that it's not going to leak, water's not going to come past it. So being an FD rotor housing, we use a little bit of 3-bond just on the legs. Now in the water seal area there, you can see that, we just put a tiny dab of 3-bond on that, a bit of silicone, just to ensure that we don't get any leak. Okay, I've got the center rotor ready to go in. Now we've got some assembly lube on the bearing, some assembly lube on the gear. Before we do put that in, last thing that we'll check is that our apex seal goes through nicely in the slots. Make sure there are no burrs, hasn't been bruised, hasn't fallen over. Okay, and they're all nice and free. The other thing we'll check, we'll just make sure all our springs are nice. None of the seals have tried to fall out. And they're all good. Okay, so the housing's on, we put the rotor in, I've got all the apex seals started to go in. Now everybody does this a little bit differently. Some people like to put the rotor on and then drop a housing over it. I put the housing on and drop the rotor in it. That's just what works for me. The other thing that people might do, or the reason I do what I do, because it works for me, is I do glue the assist piece on the apex seal. I do that so that I can put the apex seal in with the assist piece facing down. Now the only reason that I do that, we see that down in there. The only reason that I do that is so that when I'm stacking the engine and putting the next plate on, rather than have an assist piece floating here, and even if it is glued, because they are under spring tension, it has the potential to jump up and jump out. Now you may see it, you may not catch it. You might get the plate down, the assist piece is jumping up, and what will happen is it'll get caught right in here. And you'll see it on an engine that you've pulled apart, and it has this big groove right in one area where it's tried to turn, and then it's been forced down. It does leave a burr there, it does do damage to the housing, so that's why I glue the assist pieces on and put them inward. It doesn't make a difference. It's the corner seal which is going to run over the bridge there, so it's not going to affect it whether you've got the fixed end or the assist end of the apex seal going across it. Now they're all home. Now I just put a little bit of assembly lube on here so that we're not turning it dry. Now we can see got one of those epoxy blemishes in there, one of the porosity holes. So I'll put a bit of schmutz on that before that plate goes down and make sure that that is not a potential for a leak. Now before the crank does go into the engine, I'll check this journal again, or not again, I'll double check this journal. Once that crank's been put up in that rotor, I do not want to be pulling the crank back out to make any adjustments. We've also got to put our oilers and our springs and balls in there, and yeah, then we can start the assembly. So even though we'd previously done all this and set our bearing clearances, or made sure they were what we wanted, it doesn't hurt to double check, because it's very easy to make a mistake. The phone rings, someone comes in, you forget where you're at, you think you've done something and you haven't, so this eliminates a potential error down the road. So pop the dial ball gauge in there, we find center, we see that we zeroed that out. So put the calipers on, check that, and we are at, so we're right on 3 1/4. So we're aiming for 3 to 3 1/2. Alright, so just check the journal size again. Dial ball gauge into the gear. And check where we're at. Okay, we're zeroed. There you go, that's a brand new Mazda gear, and we've got 1/2 thou out of round there. So we'll check the other side of the gear. Okay, so on the back side of the gear, we're actually 0.25 tighter. So now if we were to set the bearing clearance off that bigger size, thinking, oh yeah, okay, we've got our 4th hour of bearing clearance, on the back side of this bearing we haven't, we've only got 3. Now we'll set this bearing clearance to the tighter side, not to the upper side, because if we say that we need a minimum of 3 and you've got 2, there's a good chance that that might pick a bearing up. Okay, so now to correct that abnormality in the bearing and to correct that bearing issue, what I've done is I've rubbed this bearing with some newspaper. Now we've got that back to 0 all the way around. So we've got that back to 0 all the way around. Now what I've done, the bearing material is, look, it's durable, but it's actually quite soft. So by running some newspaper in here on the tightest area, which was the back area, and it was out around and tapered. So by running some newspaper around, I've taken enough material off to actually get us back to a true size that we're after. So now I can check that clearance and make sure that we're right. Now, I'll put the micrometer back on the dial gauge. We are on, right on 4th hour. So I'm happy with that. So with that bearing issue addressed, we can now move on to installing the oilers, because this crank will be going in the engine and it'll be staying there. We have nothing left to do to the back part of it. Now I don't Loctite these in. We use a an impact driver just to seat them, and once they're done up and tight, that's where they're staying. And for the front, we just repeat the process. Now the other thing you notice about the motorsport oilers is the length too. They're a lot shorter than what the standard, so the ones you pulled out of an FD crank or an RX8 crank, even a standard 20B crank. They are the same length as the front lobe oiler on a 20B, which is shorter. Alright, so before we put this in, I'll put a bit of love juice on it. Make sure that's well lubricated. Okay, so the crank's in and home. I'll make sure she rotates. Nice and smooth, nothing untoward to suggest there might be an issue, and that one's home. Okay, so with the billet alloy plates, you've got a removable insert, basically a wear plate, which bolts into the center, and the water obviously flows in behind it to keep the engine cool. Some people heat the plates up. I'm not a fan of overheating the plate. It's not really required. The fit and finish on the billet boss stuff is bang on. It's size for size. So to fit the insert, to the plate, I just use a propane torch, and when you are warming the plate up, you'll see that the material actually starts to sweat. It'll get a condensation mark on it. That's at about 65 to 70 degrees, and that's all that I need to get the insert to drop into this and be bolted down. And doing that, it doesn't disturb any of the O-rings that have been put in. If you get them too hot, like I use a bit of rubber grease just to keep them in place while I'm moving stuff around. If I was to heat this up too much, obviously I run the potential the grease will melt, or you might use Vaseline, anything just to hold them in place. It melts. It allows the O-ring then to curl up or move, and when you bolt your plate in, it's a potential for it to not seat properly and have a leak. Okay, so that's in now, and like the plate is literally, it's warm to touch, but that's all it needed. Okay, so the water O-rings are installed. Just put a bit of assembly lube on the plate, and this will be right to drop down onto the engine. So with the center plate in, cranks in, we've got one long stud. Now that's it is there as a tension bolt, but obviously just that one shorter one is there so that when we do bolt the back side of the engine up, the engine doesn't fall apart when we flip it over to build the front. Alright, rear rotor's assembled and ready to be installed. Before it goes in, always do a double check. Make sure that side seals spring back in the edges. And yeah, we'll put a bit of lube on it and that'll go in. Again, I just want to make sure that our seals go through nice and free, they're not going to get caught up. And it also lines up our corner seals for when we insert the apex seals. Now the apex seals and springs are all in. Pop them down. Now when they just drop down like that, it's usually a good thing. The last thing that we want to be doing is forcing an apex seal down a groove. It's usually a sign that something's wrong, that they should just slide in there. So you've either got a corner seal on the bottom side has moved, the spring could be in the way. Yeah, could be a couple of things, but banging it in there is never going to be a good result for anybody. Now whilst the engine is in this position, a good idea before anybody forgets is to pull the rear plug out of the crank and we'll seal that up. Otherwise we'll have an oil leak on startup. We just use a bit of thread sealer on there, and it is a tapered thread, so once you do that up tight, it's locked up, and that will stop the oil from coming back out through the crank. And yeah. Now I've got our O-rings installed in the rear plate. Next step will be we'll warm this plate up again to fit in the wear plate, but the two other things we'll do is we'll put the rear gear in it and I'll put the rear relief valve in whilst it's all slightly warm, and that way it'll all cool off nicely, and then that'll be ready to go together. Okay, so we've got the wear plate installed, the gears installed, we've got a relief valve installed, got an anti-rotation pin installed, our water O-rings. Now this one is ready to go on. I put a bit of lube on that bearing and gear, and she's good to go. So with the rear plate on, we're just about right to turn this one over. We'll need to put our nut on there. That'll allow us to turn the engine over to build the front side. The other thing is we'll put the counterweight on. Now we don't want anything on this taper. This taper needs to be spotless. So we'll get some brake clean and we'll clean that up. So a little bit of brake clean on a rag just to get any oil off that taper, so that when we do put it up we know that seats and it's locked on. So we want to make sure the corresponding taper is clean and dry as well. So a bit of brake clean on there so that can go on. Now that we've got the counterweight on there, it's the first real opportunity we're going to get to rotate the engine. Make sure we've got everything smooth. That feels good. Alright, that's starting to look really cool. I actually like that polished look now. I was cursing it a couple of days ago when I had to polish it, and that's looking good. Now the next two important things that we need to do are get that taper clean, dry and free of any oil, and put in our oil jet before we put the front lobe on. Alright, so that's clean. We're clean there, and that can go on. Feel the key to line up. Yeah. That's it. Now we shouldn't be able to lift that up. That's locked on just with that much. I'm trying to yank on that and that won't move, so I know that tape is good. Now we can start putting water retention seals in and do the front of the engine. Alright, so I've got our dowel pins in, water O-rings in, a little bit of love juice. Now we'll put the housing and the rotor in there and finish the front half off. Alright, front rotor ready to go. Just double check, make sure our springs are all right. Put some lube on her, and then that'll go in. We'll just check that our seals fit in freely. Nice. Alright, so our apex seals and springs all done, right to go down. Now, same as the front, the rear, the front has a single stud so that when we do wind the engine over, if we need to, or we will need to wind the engine over to put the studs in from the back, but that'll just stop the front of the engine falling apart. So now we'll put a bit of schmutz on here and drop the front plate on and torque it down. Once again, we'll just warm this up. We'll drop the wear plate in, the gear in, and yeah, ready to go. Okay, so the front plate is now together. We've got the wear plate in, water retention O-rings in, gears in, lubricated, all ready to go. Okay, so front plate on, we'll just nip that up. Now, what I'll do, what we've got on this engine is we're running 7 through studs in the kit, so I'll put the stud through this side. Because we've only got the one here, it's actually pulling the engine on an angle. That's why we only nip them up hand tight, just enough so the engine doesn't fall apart when we rotate it. So we'll put a longer stud in and nip that one up, back the bottom one off, and get this thing squared up, and then we'll check our end float and start torquing the barrel up. Okay, so we've got a couple of studs in it. Everything's just nipped up hand tight now. Got perfect end float, and I think that looks $1 million. Alright, so I've got our first round of torque sequence done, and the engine turns over very, very freely. It's nice. End float. Beautiful. Things really starting to look sharp. Alright, so it's time to set the end float. Now, pull this up. We zero that. And we're right on 4th hour. And that's what I like about the billet boss plates. Doesn't matter what we use, I already know what spacer I'm going to use to set that end float and how much I'm going to have. Every time we actually now just buy one size spacer to set the end float whenever we do one of these billet engines. So now that the block's all torqued up, we torque them up to 40 foot-pounds. End float's been checked and measured. And to give you an idea on just how good the alignment is in these billet boss plates, hopefully you can see this. It's just one-handed. Perfect. We're not going to get any better than that. It's floating. Alright, so we're right to put a timing cover on this now. Double check everything's on, everything's tight. And in typical billet boss style, fits like a glove. Okay, so once the timing cover's installed, the next thing you get with these billet boss timing covers is a bearing, a seal, and then you've got your little cover just to hold the seal in. Now, these are basically a size for size, and if you get them right, if I can do it one-handed, you'll actually be able to, there you go, that's how they fit. Now this won't affect your end float at all, it's literally there just to support the crank. Now where it supports the crank is, that'll locate down on there. Now if you get any crank flex, wobble, you put an alternator belt on and you rank on it, and it's that tight, it'll stop, or it'll help stop chewing out the front stationary gear bearing. Now with the seal installed, we'll simply bolt on the retainer, put the hub in, and then we're right to put a pulley on it and put some timing marks on it. And put the hub on, line the keyway up, that's it, done. we'll roll this over and torque that up. And whilst it's flipped over in this position, we'll pop in our rear dowels and our pilot bearing. Now we've got the flex plate bolted up. Now this is just so we can torque everything up. We'll pop on the Mose rock lock. These are awesome. These do every Mazda flywheel that you'll need. So we'll lock that down and we can rip on the front and rear nut and get them torqued up to spec. And that is it. The block is assembled and sealed up. The only thing left to do now is put a couple of accessories on it, a couple of plugs in the galleries, and Tom is going to have himself a very shiny Christmas present. So I hope you enjoyed the build on this one. If there's other stuff that you want to see in a bit of detail, don't be shy, send us a message and we'll do some more of these videos.